In number 7, they asked for the expression is equivalent to which of the following. What I did for myself was I broke these up into 3 separate radicals, all with an index of 4. I separated 16x squared y to the 7th. Now, this rule says that whatever your index is your denominator, whatever your exponent is your numerator. So I essentially rewrote these two to 2/4 and 7/4. The 4th root of 16 is 2. 2/4 reduces to 1/2. It was choice number 1. For number 8, I simply put in all 4 of these equations in my calculator and graphed it to see which one it was. I could eliminate 1 and 4 because 1 and 4 go the other way. Now I'm stuck between 2 and 3, so I'm going to look at my calculator. I have 5 to the negative x in y1 and half to the x in y2. I notice that my graph goes to the point -1, 2. So looking at my calculator, I notice that -1, 2 is on y2. So that is 0.5 to the x, which is choice number 2. In number 9, they asked for the 15th term of the following sequence. I know a geometric sequence. I use a G there. The nth term is going to be the first term times the common ratio to the n minus 1. So for us, this is going to be, oops, that's a G, not a 6. The first term is negative square root of 5. The common ratio, if you notice, you're multiplying by negative square root of 2. So my ratio is negative square root of 2. And now because we're looking for the 15th, we're doing 15 minus 1, and we get 14. In my calculator, I did negative square root of 2 to the 14th power, and I got 128. So negative square root of 5 times 128 simplifies to negative 128 square root of 5. Before I continue, someone asked me, how is this? This is multiplying by negative square root of 2. How is multiplying square root of 10 by negative square root of 2 equal to that? So again, why was multiplying square root of 10 times negative square root of 2? Why and how is that equal to that? Okay? Well, this is how. If I multiply these, I get negative square root of 20. And then if I simplify, I get square root of 4 and square root of 5. I get negative 2 square root of 5. Okay, this is how they're equal. Anytime you're given a triangle where you're given 3 sides and you're looking for an angle measure, I think of the law of cosines. Now in this case, because I'm looking for angle C, I know that C has to be on the opposite side of this equation. So now I'm just going to plug in, this is C, this is side A, and this is side B. So I am just going to plug in all of my values. A is 15 squared, B is 14 squared, minus 2 times 15 times 14 cosine C. Simplifying all my algebra, I get down to here, and what I have to do is subtract 421 from this side. Remember, you cannot subtract these because they are unlike terms. Simplifying, then I'm going to divide both sides by negative 420, and I get the cosine of angle C is equal to, this is positive 0.6. So what I need to do is put it in my calculator as, second cosine 0.6. When we round, angle C is about 53 degrees. Okay, so you're going to have to use cosine, this inverse cosine, you're going to have to use that when looking for an angle measure. Okay, then you would use sine, second tangent, so that it's inverse sine, inverse tangent when you're looking for an angle measure.